Hello and welcome to another video. Today we're going to solve this interval here, so let's do it. So firstly we need to use an identity and we're going to use it over and over again, so I'm going to write it down. So this identity is 1 plus tangent squared of x equals to the secant squared of x, and bear this identity in mind because, as I said, we're going to use it over and over again. It's very important when you're doing integrals of trigonometric functions. So let's start. We can replace tangent squared of x by secant squared of x minus 1, so we're doing it now. So this is the interval of tangent squared of x becomes secant squared of x minus 1 times the secant of x dx. Now we can distribute the secant of x and we can split this interval into two intervals, so we're going to do it now. So we have the first interval, the secant cubed of x dx, minus the interval of the secant of x dx. Now we need to solve these two intervals, and I have to say the second interval is not trivial, but at least I was going to say it's trivial, but it's not. Because if you don't know the technique to solve this interval, it turns out to be very difficult. But I'm just going to give you the answer to this interval because I've already made a video on this, so you can check it if you want to. And we're going to focus on the first interval. So to solve the first interval, in a few seconds I'm going to give you the answer of this one. For now we need to solve this first interval, the interval of the secant cubed of x. Now we can rewrite the secant cubed of x as secant squared of x times secant of x. This is just a nice trick to try to solve it. Minus, and now I have to give you the answer to this interval. This is the natural log of the absolute value of the tangent of x plus the secant of x. Okay, it might seem strange at first, I know, but there's a way to do that and it's not that complicated, so don't worry about it for now. Now let's focus on the first interval, and now we can use the DI method for integration, basically integration by parts, done with this very simple and nice grid. That's called the DI method. So we need to differentiate and integrate one of the two functions. Well, integrate one function and differentiate the other. So we're going to differentiate secant of x. And now you'll see why, and we're going to integrate the secant squared of x. Now, differentiating secant of x, we get tangent of x secant of x. Integrating secant squared of x, it's trivial, it's the tangent of x. Now, this equals to this function times this function, so tangent of x secant of x minus the integral of this times this, so tangent square of x secant of x dx minus the natural log of the absolute value of the tangent of x plus the secant of x. Okay, so pause one moment, because look at this. This is the interval we've started with. So there's no way we can solve this interval because all of this is meant to solve this interval. So what can we do now? Well, you see this minus sign here. So we can bring all of this integral to the other side, and the same integral plus the same interval is twice the same interval. And then we can divide both sides by 2. And then we know what this interval is. So let's do it. We divide by 2 both sides after bringing this to the other side. So we have 1/2 tangent of x secant of x minus 1/2 times the natural log of the absolute value of secant of x plus the tangent of x. Don't forget the constant and the integration, and this is how to solve this interval. This is a very good trick, I hope you enjoyed this video. See ya!